Okay, so we're going to be doing tasks 2, 3, 4, 5, and 6 today. This is the task sheet where you'll be putting your answers. And we're going to be jumping back and forth between this and Fusion 360. Excuse me. So I didn't want to just jump right into doing the task itself where you're in Fusion because I want to give some context to this stuff. So if we look at this line, face, surface, sketch, guideline, dimension, circle, square, rectangle, assembly, and part, those have specific meaning in the context of solid modeling, which is what we're doing right now, CAD specifically. So the line is the fundamental building block of everything in SketchUp. Not SketchUp, Fusion 360. Sorry, I'll probably do that a couple more times later on throughout this. All right, so I just drew a line. Now, a line can connect to other lines. So if I select this again, I just did and I missed where I wanted to put it. Connecting there, 2 lines. And then you can see how when I come back around here, it fills in. That becomes a face. And a face is a distinct instance where you have three or more lines. This can be an infinite number of lines. And what that does is it encloses an area in 2 dimensions. And as I said, you can see how it changes color. Now, when I go to solid, I'm going to do what's called extrude, which means I'm going to take a 2-dimensional object and I'm going to give it a 3rd dimension. So I'm going to zoom out just a little bit here. So right here, this is my 3-dimensional object. Now, all these different faces that I'm highlighting, when you tie them all together, that's a surface. The exterior, the outside of an object that is in 3 dimensions in Fusion is a surface. So we've talked about so far line, face, surface. Now, a sketch is where I started. This is create sketch. So if I go, we'll just add another window here. So a sketch is where you're going to start creating 2D geometry that will then be used elsewhere in the process of creating some type of 3-dimensional object. So I'm going to jump ahead just a little bit. So we have a circle, and a circle is, in this case, specifically a center diameter circle. Fusion's very explicit in terms of making sure that you understand what you're doing. So you're going to locate something right here at the center. That's where the circle is going to be. And then you're going to drag it out, as I did. I'll do it again right here. And drag it out. And I'm going to set it by the diameter. That's how I determine the size. Can do one more here. See how I can use that. Okay. So let's get rid of a couple of these. So it's just the one. Okay. This guy right here, circle. And a circle specifically is a continuous arc rotated around a center point. This distance from here to here, the radius, is consistent all the way around. Now, our 2-point rectangle, I click once. And when I click once, I release the mouse or the touchpad. In this case, I'm clicking on the left-hand side, because if I click on the right-hand side, I'll just show you what happens. I get a menu. We don't want to do that. We want to use the rectangle tool, the 2-point rectangle tool here. So we click once, and I can drag it out here. I can enter my numbers up there. Now, let's say I've done that, and I was like, oh, I'm a little bit off. So let's say I actually want this to be exactly 4 inches right there. And I want this side to be exactly 3 inches. I use my sketch dimension tool, and that, in any 2-dimensional instance, when I pull out that tool, I'll be able to adjust, let's do 1.75 inch diameter. I can adjust the size of this. Just a reminder, as we continue moving forward, I am operating in inches. If I need to change my units, I can go down here to document settings, click on units, and it'll pull up this little tab. This little tab right here allows me to edit any of the functions that I'm currently using. So let's go back and see where we're at. So we've done line, face, surface, sketch. That's where you start. Dimension, circle, square, and rectangle. So let's jump back to that, and then we'll talk about some guidelines. Now, what's the difference between a square and a rectangle? This is a rectangle. This side and this side, opposite one another, are the same. This side and this side are also the same. The interior angles add up to 360 degrees, and each one of those, in this case, is 90 degrees. So this angle right here, this angle, and this angle are all 90 degrees. Now, I'm going to transform this. Oops. So see how if I double dimension something, you get an error message. We don't want to deal with that. We want to just make sure we do it once. So it's kind of just showing you what happens when we try to dimension twice. So there's 4 inches by 4 inches. This is a square. A square, by the definition of a rectangle, this is the same as this. This is the same as this. 4 90-degree angles adding up to 360 degrees. A square is a special instance of a rectangle. That's all it is. The only difference is all 4 sides are the same. That's what I want you to write there, basically. Just knowing that there is a specific difference. So we've tackled circle, square, rectangle. So all we have to do is guideline, assembly, and part. So let's go back here. Oops. So let's say I want to put a line in here because I want to put a series of, a series of circles, but specifically along this line that's angled. See how it breaks it up into 2 pieces? Right now, that line is acting as a divider. It creates this shape and this shape down here. If I click on it, and as I said, this activates this menu over here, I can change this line to a dotted line. It's for construction. This is a guideline. Guidelines are specifically put in drawings so that you can use them for construction. If I were to go to create this, to turn this into a 3-dimensional object that I then 3D print, guideline's not going to show up. It's not going to change anything. It's not like this top piece is going to be able to come off or something like that. See how it still highlights as a square or a rectangle? This is independent of this, but it's used for construction. Okay, let's do something else here. So I'm going to get rid of that. I'm going to get rid of this. I'm going to zoom out a little bit. Oop, went the wrong way. Okay, I'm going to jump over here. I'm going to hit solid, and I'm going to extrude this. Okay, I'm going to twist this around so you can kind of see it. And I'm going to push this up 4 inches. Now I'm going to start another sketch real quick. I'm actually going to sketch it in the same plane as this, but I'm going to put it to the side. So let's do this. I'm going to create a cylinder. So I've got my circle. I'm going to click extrude. And I'm going to drag this. So it's just like that. So it's just like basically like the blocks you played with when you were a kid. Now, if I highlight this, what I can do is I can go up here where it says assemble, new component. It's going to change this over to a component. So you see right here how it has a new name, this right here. I'm going to change this to a component as well. What this allows me to do is change the nature of this. This guy right here, so I can move it around as a unit. I can move this guy around as a unit. I'm not just grabbing a line or something like that. So what I'm going to do, you see how I can drag this over here because this was created in this area or parallel to this, and I can move it around free form now. See how I can move it here? Originally, it was locked into being in a plane. I didn't really show you that, but I can go over here and create a joint. So let's say I want to take this face and this face, and I want to mate them like that. Just looks like a little like Lego block thing. That's the power of using an assembly. And so I had two parts. A part is essentially the result of a sketch or a drawing, depending on how far you take it. This, I did it all within one drawing, but a better way to deal with it is if you have something that you're constructing, each part is its own drawing. And the reason for that, it helps you stay organized, it helps you build things, and inevitably when something goes wrong, you can fix it. Now, an assembly is two or more parts put together. That's all it is. An assembly is two or more parts put together to create something with greater complexity. Whereas a single part is a standalone. It is the smallest unit that we're going to find. I think that was the last one on this. We got dimension, circle, square. Yep. So part and assembly. Now we're going to go down here. 3 lines with a dimension. I'm not going to do these explicitly. Okay. I showed you how to make a line in this explanation up here. We went over how to make a rectangle and a square. And we went over how to make a circle. What you're going to do, again, just to reiterate this point, and jump back to here. Actually, we'll just create a new window here. Sketch. Choose the plane you're going to be in. I generally start on the top plane because think about if you're looking down on something, the top plane is where you want to be. So, line, whatever size it needs to be. See how I still have an active line here? And see how I have a degree measurement? If I don't want that anymore and I hit escape, which is in the upper left-hand corner of your keyboard, that allows me to get out of that active line. See how I'm free again? Okay, got my square or rectangle, depending on what I'm going after. And then I have my circle. If I want to edit any of them, and this is the second time I'm showing this, so don't worry if you 6 inches, 2 inches, and then we'll do 3. Oops. And if you screw up with any of them, you can just double click them and they'll be active again. And then finally, right here. Okay. Oops. Hit enter after any of those. Okay. 5-inch circle. It's a lot bigger. So we'll blow that away, get rid of it. Don't want to save it. Keep this little building block. And then we're going to go back here. Okay. Let's see. Hit that. I want you to try to make the U shape yourself. Okay. Second stop here is advanced 2D sketching. The reason we're doing advanced 2D sketching is because you just did basic 2D sketching. And if we were just going to focus on cubes and cylinders and stuff like that, in all honesty, we would have just stayed using Tinkercad. Just so you know, Tinkercad and Fusion 360 are in the same CAD family. Fusion allows for a lot more stuff to be done with a model. If you ever feel like Fusion is too much, you can move over to Tinkercad, get an idea, and then we can actually bring that whole thing into Fusion, just so you know that. All right, so we're going to start with concentric circles. I'm not going to do it exactly the same size as I have listed. The reason for that is I want you to show that you're able to read, comprehend, and then execute these things. No big deal. So first thing, concentric circles mean they are sharing a center point. So I draw my first circle, I draw my second circle, I draw my third circle. I could, right here, see how it does that? I could just go straight direct entry. And what that means is I don't actually have to go back and use the sketch dimension tool. Some of this stuff is some of the reasons I do things the way I do them is because I was trained on several different types of CAD programs. So essentially what happens is this is muscle memory for me. This is how I do it elsewhere. So you can see I'm a little bit far out on this one, so I can move that dimension up. Make sure I can read them. Just out of common courtesy, makes it go quicker. We already know I'm bad at getting stuff back quickly, so let's not make that any harder. So concentric circles, circle inside another circle, inside another circle, all sharing the same center point. If I were to just draw a circle here, that's not concentric. That's just a circle somewhere in a circle. Okay. Next thing, right triangle. Right triangle has a 90-degree corner, so same thing, start a sketch, grab right here. Going to make it easy on ourselves. I'm just going to do, let's see, a 5 inch by 5 inch. Oops, I have to actually hit that tool. There we go. 5 inch by 5 inch square. This right here is just showing that you can take basically modify something. That's our goal here. So I clicked up here. I dragged, brought down, put a line right across there. And our goal here is trim. We're going to use the trim tool to remove this. We're going to use the trim tool to remove this. See how this is getting angry? Constraints and or dimensions removed during the operation. What that's telling us is that you saw how I had that dimension across the top. Probably just want to put it back here. Okay. And hit enter. I still have a warning and I'll just close it. A warning is not like a stop, this isn't going to work. It's just a, hey, you might want to put that back here because it's going to change when you do something else. Okay, now back to this. You see 3 things right here. First one should be a drawing of your square. Second one should have one of the lines removed. And the third one should be the final triangle, all with dimensions. Our next stop in task 3, advanced geometry, is going to be this beautiful drawing right here. This is putting it all together and adding one more little thing, which is this fillet, which I'm going to talk to you about later. This I am going to draw exactly for you. So if you follow my step-by-step instructions, you will get this right. The one thing I do want you to know, I put something else in here. You need to read this. If you do not read it, you're going to miss something and you're going to get points off, mainly because you missed something important. This is also so I know that you didn't just copy this and put it down there. Yes, I wanted to make sure that you actually tried this. So go back to Fusion. We're going to do a new design. This one, I'm going to jump back and forth a couple times just so I make sure I get the directions right. So I'm going to start by creating. So let me back up for a second. First thing you want to do is you want to find the most simple shape to build off of. In this case, it's a 4 inch by 8 inch rectangle. So we're going to do that. 4 inch by 8 inch rectangle. Okay. 4 inch. Oops. Actually, let me get out of that. Okay. I'm just going to do this so it's quick. There is a shortcut for that, but 4 inch by 8 inch. So if I jump back here, 4 inches from top to bottom, 8 inches across. Next thing I'm going to do, I'm going to put some guidelines in. So remember how we talked about lines? Go over here. I'm going to choose this, and I'm going to put that guideline straight across the center here. I got to move this out of the way. Okay. I just realized that that's probably not in the right place. So I'm going to put this guideline up here. So see how it says 0 degree? See how I can move it up and down, and it's 0 degrees is where you want to make sure that you're at. Next thing you want to do, you want to put another guideline in across here. And they're going to go right in the center. Oh, where's my degree measurement? 90 degrees. There we go. So I got my 2 guidelines. I'm going to jump over here. I'm going to grab my dimension tool. It's pretty simple math. This is going to be 2 inches. This one's going to be 4 inches. Keep it down here. Sorry if you hear my dogs in the background. They're wandering around and doing dog things. such as randomly burping, which is gross. Anyway, moving on. So what I'm going to do here, I'm going to go back to my lines. I'm going to click off of that. This one here is center line. Technically, this is something you'd use if you were going across the center, exactly like I did. Not really worried about that. Just want to show you the general use of guidelines. First thing I'm going to do, this is the line that connects. Come on. There we go. This is the line that creates this. I'm not going to use the trim tool yet. I'm just starting here because it might mess up a dimension or two. Next thing I'm going to do is I'm going to locate my circle, which is going to go at the center intersection. You've got this other line right here. That line right there is going to be the axis. So 1.5 inches, that's what I did on this one. Let's double check to make sure that's what I was supposed to do, 1.5 inches. The last thing I'm going to do before I do my final trim is use fillet. So if I want to round a corner out, instead of like trying to get a circle perfectly positioned and then cutting the circle up, excuse me, there's a tool that creates a shortcut. It's called fillet. I click it. I want this corner to be rounded. See how it puts that red line in there? Click there. I can choose the radius of it, and it does that. I did lose a dimension somewhere along the lines, but that's no big deal. You can just close it, or it just changed how it was referencing it. Okay. So next thing, got to get rid of this stuff over here. It's going to affect my 8 inch. So I'm going to move my 8 inches down. You guys see how I did that? Just grabbed it, moved it, just like dragging and dropping on a phone. Okay. That is how you create that figure. So here's the angle. Here's this. Here's this. Here's this. Now I do want to show you something. If I'm going to turn this into a solid, see how I can click on that and then extrude it up? Because I'm clicking on the outside of it, let me show you this. Because I'm clicking on the outside and I'm excluding the circle, that's how I can make a cut in a two-dimensional object without doing anything else. There are different ways of doing this in different different CAD programs. So you'll you'll create your version of this, take a screenshot, put it in there. All right, task 4. 3 more tasks to go. We got this. All right, so, oh, bother. This got a little funky. Must be, this happens to everyone. You create a big document and stuff moves when you move stuff around a little bit. So what we're going to do here, see these axes? Red axis is something, green axis something, blue is something. So we're going to hop back in. You need to explain what a coordinate system is. And I'm going to explain that by going back into Fusion 360. I'm going to open yet another document. Okay. And I'm going to open a sketch. And I'm going to zoom in here a little bit. I'm going to go down. See how when I change these planes, numbers appear? So this is a really good way. See how I've got different colors on these axes? Okay, so let's just do this one. So this is our top view. So we're looking down on it. This plane is going to be the XY plane. The red axis, or axis. That's right. The red axis is going to be the x-axis. So if you think about this in terms of if you've all graphed something at this point, like an independent and dependent variable, you've got a number of people who said a response of 3 on some type of chart. You're putting a graph and you're looking for how that information creates a trend line. You've all graphed something. Now, what this is doing is taking that graphing, because if you should be doing it proportionally, what this is doing is it's basically assigning every point in three-dimensional space 3 things: an x coordinate, a y coordinate, and a z coordinate. So x is red. Oh, I can't really point to it because it keeps shifting. So x is red, Y is green. So two-dimensional plotting. And then blue is Z. Z comes out of the paper. So if you think about it, like the floor at school, each one of those tiles is a foot by a foot. So if I start by the door of my classroom, and that's 0, and I want to figure out what the point is at the top of one of the desks, what I would do is I'd count over X, up Y into the classroom, and then up Z to the top of a certain point on the top of the desk. It allows us to graph, essentially, three-dimensional space. And when we graph that three-dimensional space, we're able to connect those points to create solid objects. So everything that you've been doing up until this point in this program is basically really advanced graphing, and the computer's doing all the measuring for you. Now, if you look in the middle, there's that thing, that dot, that's the origin. At that point, it's 0, 0, 0. So X is 0, Y is 0, and Z is 0. And that's how you would report out X, Y, Z. Now, if you go to the left of that, you can see how the numbers turn negative. If you go to the right, they turn positive. If you go up the green axis, positive, down the green axis, negative, up is positive for Z, and down is negative for Z. It's a convention. You could start at 0 and then just go infinitely. This way, it's just an easier way of, so you don't have really big numbers when you can avoid it. Now, if you look here, what we're on right here is the XY plane. The XY plane would be our top view. Now, our front view would be our ZX plane. And then our right view would be our YZ plane, or ZY, depending on what convention you use. And the reason I'm telling you this is not because I want to add something that's even more confusing, but I want you to think about these surfaces as a table that goes on and on and on and on forever and ever. And that's what a plane is. Now, it doesn't really matter for what you're doing right at the moment, but when you go to put your letters from your name on top of your keychain, you need to make sure that you're not in parallel planes, meaning that you have one thing that is in the XY plane and something else that's in a plane that's, it looks parallel to it, but it's not in that same plane, that same surface. So it'd be like you have a desk with two levels, one higher level, one lower level. That's what parallel planes are. You're not going to be able to get between the two of them. So that should answer everything for coordinate system explanation. And then also this stuff. This should be pretty quick. Get some good points for that. Okay. The next stuff. Geometry, cuboids. So this is going to be taking those things. We've done this. I've shown you this, but I'm going to do it again. Okay, create a 6-inch circle that is extruded using the extrusion tool to 6 inches. Okay, so you're making a cylinder. Create a 5x5 square and extrude it to 5 inches. Create a cuboid that is 8x6. That is a new sketch. Do not delete the 5-inch cube. Okay, place the smaller cube on top of the larger cube. We did this back here. Oops, not that one. Not that one. That one. Okay, we created. So I'm going to go back a little bit on this. Okay, 2 different shapes. Just want you guys, little review here. Okay, so see right now, we're at the component level here. I'm going to go back. Let's see when it breaks out. Okay, so I'm at sketches. So if I try to move this, see how it doesn't move? Now, if I highlight this and turn it into a new component. Oops, I actually accidentally grabbed both of them. Oh, let me go back here. Make sure I get the right thing. What is going on here? Okay. Extrude. Clicking on the wrong thing. All right. Assemble, new component, standard, selected. Okay, there's our component. This guy right here. Assemble, new. new component. Okay. Now we want to put them together. So I've taken my two drawings. I created this guy right here. And if all I want to do, so like I said, I want to put this one, I want to put something on top of something else. So what I'm going to do is I'm going to come over here. I'm going to click joint. I'm going to take that. I'm going to take this. And it's fine. All you have to do in this case, if it ends up in a weird orientation, just rotate it. I'm not going to be a jerk about it. If you get the two things to stick together, by all means, you win. Okay? Hopefully that makes some sense. We've talked about this. This is just getting the application. The stuff that should take you a second to do is probably this part. And then, again, create a 6-inch circle and extrude it to 6 inches. One other thing while you're doing this. So you go back to this component here, origin bodies. No, no, I didn't want to do that. Revert position. Sorry about that. So what we can do is we can put, so like here to here. Sorry. Utilities. Measure. So should be able to don't worry about it. Okay. So just demonstrate that you're able to do that. So it'll do that. Just click create driven. We're using this just as a labeling method right now. No, that didn't work well. Just ignore what I'm doing right now. All right, we're gonna go back and skip over that. So just make sure if you can't get a dimension in there, I'm not gonna knock you on it. Okay. Holes and cuts. Draw a 5-inch square. Draw a 2.5-inch circle on the same sketch. Using the extrude tool, select the area around it. Okay. Showed you how to do that back here with R. So again, I'm not going to, actually, I'll just do it doing this, using this. I'm just going to draw a circle. I'm going to go click solid, extrude, click this area. That's one way to make it work. Okay. Make sure that extrusion is the right height. And then the other way to do this is create a hole. You're going to do it on that surface. You can put it anywhere. And then let's say you want it 0.5. This is a really good way to use guidelines. So, so again, one thing, so like this, if I need to edit that, I can go right here. Delete it if I need, sorry. There we go. Okay. Edit feature. See how I opened it back up? Here's this. What I didn't do is I didn't go all the way through. I have this type hole selected. It's fine. Like I'm not worried about if you go all the way through it. If I need to, so 0.5 inches is my depth. I can go 1.0 and I'll go all the way through. So you can see that. So that's how you do the rest of task 5. So you draw your square, 2-inch, then extrude the thing so you have a hole in it. Then you add another hole. Last thing, task 6, 3D text. Woo! This should be simple. Theoretically, maybe. Okay, so finally, go back here. You're going to create a drawing. Boom. You're going to go create text. I've moved it up here because I'm going to be using text a lot. I'm going to create a text box just like if this was a slideshow. See, it says sample text. Write your name. Mr. Carpack. No, there are no C's in my last name. Okay? You can do it centered. You can center it in the box. Whatever works for you. So height, character spacing, you can modify the spacing. You can modify the text itself. You do want to have a thicker text. See how this is like that? You don't want to find something that's real thin because it's going to be hard to 3D print because that's where we're headed with this. So I'm going to use this guy right here. I'm going to hit OK. Next thing I'm going to do, I'm going to go over to solid. I'm going to go to extrude. I'm going to, so for thinking ahead, our 3D text. So I'm going to select all the letters here and I'm going to punch in 0.25. Okay, hit enter. What's going on here? Why are you being like this? All right. So we'll do negative 0.25. Just for some reason, it was being a little finicky. Okay, see how, so the next thing you're going to do is you're going to select, okay? Make sure you select everything, okay? What you're going to do in this case, assemble, come on, new component, hit OK. And then what that is done, oh, oops. I don't know why I did it like that, but whatever. See how I can add, this ends up moving around. We don't want that. Let's see, can we link this together easily? Assemble, new component, standard, external. Form bodies. Well, just make sure you're grabbing the whole thing. Doesn't matter at this point. Okay, so it's all extruded. What we'll do is we'll end up moving it as one whole thing here. Just have to be careful you don't end up moving like that. Okay. Let's see. Actually, you know what we can do? Let's do this real quick. Sorry. Rigid group. That should do it. Okay. So what that should theoretically have done. There we go. That allows us to move the whole thing up and down when we need to. Okay. So write your name. Take a screenshot of your. Shh. Shh. Sorry, dog going off. All right, your name with the text tool, screenshot of the parameters. That's in that features box over to the side, and then your name extruded. Okay, apparently one of my dogs is deciding that he needs to bark at things, so we're going to wrap this up. Thank you very much. If you have